Okay, Xiomara. Okay. Okay. So the topic we discussing today is piecewise defined function. It's relatively easy. It's no big deal. But don't worry because I want to explain one couple of examples. And after that, in the review packet, we go over again to this. Okay? This is no big deal. This is no big deal. It's only to be familiar with the notation with the piecewise functions. Okay. Okay. Ready, guy, to pay attention? Ready? Everyone is ready to pay attention? Okay, super. We start. Let me try to explain piecewise function. Look, the symbolic way to represent the piecewise function is when I'm using the same function notation f of x. But this is a function that you define in different pieces, in different intervals. So you open a big curly bracket like that. And you copy, for example, one expression, minus 3x plus 2, and you put a condition for this. If x is less than minus 2. So this expression is valid only for this condition. Okay? Then we have different pieces. We have, for example, x squared plus 1 if x is in between negative 2, o sea, consider equal negative 2 and positive 3. And the last piece, because this piecewise function contains 3 pieces, is a constant function that is just for if x is greater than or equal 3. So you see, wow, 3 pieces. Normally we have 3 or 2, depending, or 4 or 5 or 1,000. But this is not important. The important is, let me try to understand very well this idea. This is my famous all real number line. Positive infinity, negative infinity, 0 here in the middle. And we have different, like a transition point, negative 2, negative 1, negative 2. Another is 3, positive 3. 1, 2, 3. Okay. So I understand que before, let me use a different color to emphasize the idea. Before negative 2, que es this? Before negative 2, que es this interval. By the way, no include negative 2 because I don't see any equal sign here. Therefore, parentheses. The expression que es valid is this expression. The expression que es valid is minus 3x plus 2. So see, my point lie inside this interval. I using this expression. Otherwise, no. Suppose the second interval, que es this interval, green one, is bracket 2 because include 2 to 3. No include 3. So you are inside this interval, we're using this expression. Finally, let me using another color, maybe this color, no, yellow, maybe yellow. So you have inside this interval, but wait a second. Yeah. So you have inside this interval, okay, by the way, this interval is bracket here to positive infinity. We're using this expression. Okay, this expression is just 4, so y equal 4, or f of x equal 4. Entonces, now the process is easy. Okay, well, okay. Suppose, professor, what is the question? Well, the question is evaluate this piecewise function in different given value. For example, you evaluate negative, you evaluate -3, you evaluate 0, you evaluate in 5, you evaluate. So the process is easy. Is you try to find, for example, let me start for 5. 5 is here. This is 3, 4, 5. Es obvio 4, 5. Es obvio que 5 lie in the yellow part, and the yellow part corresponds with this interval, and the selection is the function 4, and the answer is just 4. In this case, the function do not depending of the x, therefore it's a constant function. Now I put just 4, but for example, -2. Well, -2 is here. The -2 is confusing, very, very confusing, because -2 belong to the blue or the green. The green, because it's bracket, included -2. So this equal sign indicate me que -2, actually, the point, -2, entonces, okay. Angelina, 8. What 8? No, Angelina, no, look. You select, look, Angelina, you select. So first of all, you need to understand que at x equal -2, you need to select the green expression. Okay, the green expression is x squared plus 1. And you evaluate, I recommend this convenience notation, is you put such that, and you plug it in -2, no? Entonces, -2 square, be careful with the parentheses and the sign plus 1. So I select the green expression, no the blue. No. Entonces es 4 F5. The answer is 5. Do you understand this, Angelina, or no?
Why did you put the green instead of the blue? The blue is negative.
Because specifically at x equal -2, this point belong to the green part. How do you know? How do you know?
Equal. Yeah.
Exactly. This is the clue. Equals.
Thank you.
And be careful with the transition point. So the transition point is the point in which you change from, for example, from blue to green, or from green to yellow. Entonces, in this transition, be careful in what interval belong this point or not. Okay, -3. Bueno, -3 is obvious que here, right? -3, -4. So -3 belong to the blue, and blue is this interval because -3. Okay, another way, without graphic representation, you substitution -3 here. -3 is less than -2. Oh, this is a true statement. So you select this expression, que es -3 x plus 2, evaluate at -3. Entonces, -3 multiplication by -3 plus 2. -3 times -3 is +9, and +9 plus 2 is 11. Any question? And 0, bueno, 0 is obvious que 0 belongs to the green part. You put in 0 here, for example, 0 is less than or equal -2 and less than 3. Okay, 0 is less than 3 and greater than -2. Perfect. Matching with the condition of the green interval. So you select one more time, x squared plus 1, que es the expression for the green interval, such that x equals 0. Entonces 0 squared plus 1, the answer is 1. End the story. Super easy or super complicated? Let's practice more. For example, let's practice evaluating in 1. Let's practice evaluating -4. Let's practice evaluating and 2. Now let's practice evaluating 6. Help me, guys. 1. In what interval lie 1? In the blue, in the green, or in the yellow? Green. Entonces you select the expression x squared plus 1 at x equal 1. Entonces 1 squared plus 1, 1 plus 1 is 2, end the story. -4, in what interval lie? -4. In the blue, in the green, or in the yellow? Blue, 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 Angelina. Entonces you select the expression -3x plus 2. Evaluate at x equal -4. Entonces -3 times -4. Be careful. This minus is the coefficient of -3. And you substitution -4. You replace x for -4 plus 2. This is 12, 14. En 2 es obvio que es green, ¿no? 2 is here. Es green. Green is x squared plus 1, such that x is equal to +2. This is 5. This is similar to -2. And 6 is here yellow. And 6 is just a constant for end story. Any question? Super clear? Super clear. Okay. Do you want another example similar or enough? Do you consider? Remember that we have always short in the time. Pero no, you are my customer. You need to see another example similar or no? No? Yes, no, yes, no.
I just have a question on, I understand the mathematic part. I just don't understand why between the blue and the green, for example, you have a parenthesis and a bracket on the graphic.
So I suppose that you need to see that the condition x less than -2 is equivalent. It's equivalent to say, let me make a zoom. Is the bunch of value, the interval between -infinity and -2. No including -2. So es que I try to represent graphically in the blue interval. Make sense for you or no? Yes or no, miss?
Yeah.
And this other condition, que es the second one, que is -2 x less than 3. This is equivalent to say bracket -2, 3 parentheses. O sea, es the green interval. And finally, the interval x greater than or equal to 3 is equivalent to say bracket 3, infinity. This is the yellow interval. Now, the complicated part is discover in what interval lie the specific value that you want to evaluate. 1. So I saw one lie here. So one lie in the green interval. Therefore, I select the expression que corresponde a this. So the complicated part is discover in what interval lie, and this allow me selection the expression. When you select the expression, just plugging in the value and end the story. Crystal clear or no? Crystal clear? Clear. Super. Very well. So you consider que es useful to make another example? Oh no. Similar. I have here in my paper another example. Suppose the function g of x, suppose in the test is given this. And the first piece is one constant function if x less than -1 is x minus 1 square, the expression if x is in between -1 and positive 2, including both endpoint. And 1/2 x minus 2 if x is greater than 2. Remember, this is the format. The format represents expression, 3 expressions, and associated with each expression, we have the interval in which is valid this expression. And suppose que in the test, I ask you evaluate the function g and -5, evaluate the function g and 0, and evaluate the function g and 2. And that's it, no more. You in the test, you evaluate 2 or 3 points, no more. And to say, okay, I need help. -5 lie in what interval lie? In the first, in the second, or in the third?
In the first?
Absolutely, because -5 is less than -1. So you discover que is belong to this interval. Now the expression que I select is just 1. Final answer. And 0, and 0, and 0, and 0. And what interval lie? 0, 0, 0. In the first, in the second, or in the third?
Second.
Second, it's obvious. So now the selection is easy. You select this expression and plug it in 0. Question, go ahead. 0, 0, 0. Look, so you plug in 0 here, satisfy both conditions. 0 is less than 2 and greater than -1. Belong. Another way to visualize this idea is -1, 0, 1, 2. 0 is inside the interval que corresponde -1 to. This is the one graphic, you know, the one image is much better than 1,000 words, and much better 1,000 symbolic mathematical symbol. So now plugging in 0 here is 0 minus 1 squared, is -1 squared, guess what? And 2, what do you suppose is 2? 2 belong to the first interval, to the second interval, or to the third interval? What do you think? Thinking, tricky. 1, 2, 3.
The third interval?
No,
oh.
because I confuse you. Because equal sign and 2 belong in the second. Here we have no equal sign. Therefore, we cannot select this, never, in this example. This is completely to confuse you. Entonces, G and 2, the selection again is the second expression, and you evaluate at 2. Entonces, 2 minus 1 square, 2 minus 1 is 1, 1 square is 1, the answer is 1. Wow, the answer is 1, 1, 1, 3, 1. Do you understand or need more point? Suppose que I evaluate in 4. What do you think about 4? Belong to the 1, 2, and 3?
To the third.
To the third. Entonces, 1/2 times 4 minus 2, because I select that expression. Plugging in 4 here, 4 divided by 2 is 2, 2 minus 2 is 0. The answer is 0. Any question? No? Okay, good. Okay, entonces now I want to introduce another topic. It's no big deal in my opinion. It's easy. I promise, guys. I promise in the review packet we go over again to the piecewise function, no? This is the combination of the function. Combination of the function. And this is relatively easy. And it's a typical question in the test because we can combine, suppose we have two functions. Suppose we have two functions, it's given in the test. F of x, wait. Suppose we have two functions, f of x and g of x. And we can combine using different possibility. The most elementary possibility is the arithmetic operation, addition, subtraction, multiplication, division, no? Suppose that the notation that we are using is you adding f of x plus g of x, addition. The symbolic way to indicate is f plus g of x. This is symbolic. But in the test, I asked you using symbolic way. So you need to be familiar with this notation, no? F plus G is F is just take both and connecting by plus. That's it. Now likewise, subtraction. In that order, F minus G. Multiplication is F of X times G of X. The symbolic way is F dot G of X. And division, suppose F of X divided by G of X. Is equivalent to say F divided by G inside the parenthesis, and the argument is X. This is super easy. This is super easy to understand. What is the complicated part? The complicated part is state, que es the second question. The second question, so the first question is, okay, right, express your new expression after the combination two functions. Okay, this is easy. This is algebra. Now, the second part is state is domain. And state is domain is look. In every case, the domain is domain of f, capital DF represent domain of this function, intersection domain of G. So basically, you need to satisfy both domains. See, one domain is failed, it's not inside the domain of the total combination. Except this is valid, this idea is valid in addition, in subtraction, exactly the same, in multiplication, but in division, no. In division, it's a little bit more complicated. It's domain of F, intersection, domain of G, intersection, or intersection of subtraction minus the value X such that G of X is 0. Because this is a restriction, no? It's a restriction. So when the G is 0, division by 0 is undefined. The undefined is totally outside the domain. Remember, the idea for the domain is the value, the set of the X value such that my function is defined. See, it's undefined, it's completely out the domain. Let's see example to understand the idea. It's no big deal. For example, it's given two functions. Two functions is given. F of X is equal 1 over X plus 3. Okay, this information is given. Semicolon, G of X is equal X over X plus 2. Okay. Entonces, en the test, I ask you, okay. Compute or find the F plus G of X expression. Expression. And of course, state is domain. So it's the typical question que combine two answers. One answer, two answers. Okay, let's do it. It's super easy. Addition is 1 over X plus 3 plus X over X plus 2. I leave it like that? No. It's not elegant. It's no. You put together in one join in only one compact expression, no? So you find the least common denominator, que es X plus 3 times X plus 2, and divide this divided by this multiplied by 1 is X plus 2, no? Plus X, que this X is this X, times X plus 3. I suppose that you understand very well this algebra. Yes or no? This is a classical manipulation of the put together in one least common denominator, no? And the rest is pretty easy. You remove the parenthesis and try to combine like term when it's possible. No? X times x is x squared plus 3x plus 1x plus 2 divided by x plus 3, x plus 2. You can leave it like that. Well, no, not like that, because you finish to combine like term. Like term is x squared plus 4x, because 3 plus 1 is 4, like term plus 2 divided by, and you can apply FOIL here. Oh no, this is totally irrelevant. And this is my elegant final answer. This is my first part, is expression. Find the expression que represent the sum to function. The second part is always more complicated. Do you understand this part or no? Clear or confusing? Clear? Yes or no? What happened, guy? Clear. Good. Now the rest is state domain. Entonces I can see, okay, domain of f, que es f is that function. Okay, remember the idea for the domain. Domain. When you have fraction, let me recall this part, que it's easy, but the student don't understand very well. Okay, domain, to find the domain to the any function, the supposition, the assumption is all real numbers, except the restrictions. So when you have restriction, you have restriction in three basic situations. Restriction number one, when you have division to function P divided by Q, I suppose que P and Q are a function, no? You suppose que Q expression not zero. This is the first restriction. Division, you try to avoid que denominator is zero, because I know que son defined. Number two, restriction is when you have a square root, one expression que I call E must be non-negative, because si es negative, is imaginary, and imaginary is totally outside the real number. And the third combination is when you have a square root but on the bottom. P divided by radical E is radical E only positive, because si es negative imaginary, si es zero is undefined, because the division by zero. This is the restriction, the classical restriction. Now, well, and another more complicated example is their combination. No? But in this case, it's easy. In this case, look. The function that we analyze is 1 over x plus 3. So you take the denominator expression, que es x plus 3, and you enforce it to be non-zero. Basically, no negative 3. The negative 3 is the bad guy in that function, because you blew a negative 3, and negative 3 plus 3 is 0, and division by 0 is undefined. Okay, entonces the domain of the function f is all real number, except negative 3, que is the only bad guy, the only hole that we have in the domain. Likewise, or similarly, domain of G is, you take the expression at the bottom, que is x plus 2, non-zero, illegal, therefore, non-negative. So what's the answer? Well, the answer is domain of this, que is the combination, is both restriction together. That you can, there are several ways to write this idea. You copy like that. Curly bracket, x such that, x no 2, no negative 2, sorry, and x no negative 3. This is a fantastic way to express this idea. However, in the test, I don't know why they ask you in interval notation. So you need to be aware to express any question, any answer, and in that way, is set builder notation, que sometimes is countable, sometimes no, and interval notation. Let me try to understand interval notation. This is my all real number line, infinity positive, infinity negative. Yeah, I know, I realize that we have a couple hole. This is a hole and this is another hole. We have 0, -1, -2, a hole and -2, and a hole and -3. So basically, we have domain is this interval I want to do in blue color. Yeah, the answer is from -infinity, comma -3, union, -3, comma -2, union, -2, comma infinity. And this answer is equivalent to this answer, but this is self-builder notation, and this is the interval notation. So say, okay. You can express it both, or at least one. But suppose que in the test I enforce it to you to represent an interval notation. Okay? And so you leave it like that, you have credit, but not full credit. Okay? It's confusing, it's clear, confusing, clear. Huh? What happened, guy?
Can you please explain again the graph and
Absolutely.
how
Look at
you
that.
get that?
I discovered algebraically that we have two restrictions, en -2 y en -3. Entonces, the representation graphically is all real number. This is my famous all real number. But I know que en -3 y en -2 we have a couple of holes. Because it's illegal. Illegal value. Look at that. Suppose que you plug in here -3. -3 plus 3 is 0. Wow, undefined. Or -2 here. -2 plus 2 is 0. Undefined. At least one 0 in the denominator is undefined. That is a reason que my domain is only the interval que I highlight in blue color. Okay? Entonces from negative infinity to -3, pero don't touch -3. Illegal -3. From -3 and -2 do not include the endpoint. No. And from -2 do not include -2 to infinity. The rest is okay. 1 point here is perfect. Belong to the domain. 1 point here belong to the domain. The only guy that do not belong to the domain is this bad guy. -3 and -2. More clear now?
Yes, thank you.
Good. Let's see the same. Let me take advantage the same example. But I want to change something. I want to change the complicated thing is division. Division. Suppose que in the test I ask you, find the expression and state its domain of the combination F division G of X. Well, okay, I try to do my best. I know that the function F is 1 over X plus 3. Remember, it's given at the beginning, right? And the function G is X over X plus 2. Okay, division is super easy in algebra. You copy the top expression, time, and flip it to second. Now our expression is X plus 2 in the top, X times X plus 3 in the bottom. End the story. I finish. This is the function que is formed by division to function. Entonces, what is the domain? The domain is, I can see que in the denominator we have two bad guys, X alone and X plus 3. Again, X plus 3 is repetition the same idea, no? Non-zero, -3. And X alone, que es the second part, non-zero. You have two bad guys. So the domain is X such that X non-zero, doesn't matter the order, and x no negative 3. Suppose que in the test, they want que you express it, this idea in interval notation. Okay, no problem. Let's do it. I like so much the graphic representation to understand the thing. So it's in 0, we have a hole. This 0. In negative 3, we have another hole. Negative 1, negative 2, negative 3. Okay, therefore, this interval is good. This interval is good. And this interval is good. Entonces, from negative infinity, comma, negative 3. Of course, do not include negative 3. Negative 3 is a bad guy. And 0 is another bad guy. Union, minus 3, 0. Union, 0, infinity. End story. This is domain of F division G. Any question, guy? No. No. Angelina dice no. Okay. Okay. Let me complicate a little bit more. Okay. Was harder. Yeah, a little bit. Yeah, of course. Division is harder than the addition, subtraction, multiplication, because includes. Entonces, si you are smart, you prediction. Que in the test I put the division, no? Or I put both. Okay. Let me try to explain function composition. Que es another way function composition. Function composition is another way to combine the functions. Okay, not only using arithmetic operation. No. Function composition. Let me try to explain function composition. Suppose we have to function. Suppose we have to function. F of x is equal, easy, no complicated, x squared. Parabola. And we have another g. And g is a linear function. Suppose 2x plus 1. I need to form it. Look, this is you need to be familiar with this notation that I want to explain now. It's totally new. F composition G. It's look like a 1 0, but it's not 0. It's a 1 weird 0, like that. This is equivalent. So this is equivalent. Look, it's a combination F and G, but in different, totally weird way. Look, you have to function. And any element in the domain, you plug it in the first function. Okay? Que es the function que es close to the argument. Que es the x is the domain value, no? O sea, basically is the operation of this is you plugging in any value of the x first and g, and the result of the you plugging in f. Let me explain it down. Suppose I want to evaluate f composition g, evaluate at 2. Well, this is equivalent to say f bracket g evaluate 2, and you compute it separately. G and 2 is plugging in 2, and G is 2 times 2 plus 1, F5. 2 times 2 is 4 plus 1 is 5. Okay, entonces, so far we have F evaluating 5, and you evaluate 5 in F, que es 5 squared, que es 25. Do you understand the idea for the composition? It's like a chain rule, chain of function. Entonces es important, extremely important, the order. The order is extremely important. Si I switch the order, not necessarily the answer is the same. Suppose que I try to compute this. Suppose que I try to compute this in different order. I switch the order. It's no community. You expect the same answer? No. A completely different answer. So this is G bracket F evaluating 2. So F evaluating 2 is you plug it in 2 and the expression of the F, que es x squared. 2 squared is 4. Nice. Now you evaluate G in 4, and G in 4 is 2 times 4 plus 1. 2 times 4 is 8 plus 1 is 9. Oh, you see the answer is completely different. This answer and this answer. So in general, I guarantee you, in particular, yes, we study not this chapter, another chapter. In general, F composition G is not equal G composition F. Keep in mind this, in general. In particular, it maybe is. In general. Ajá. Entonces, you understand composition a little bit or no? Yes or no? I need to understand si you understand. I need to be clear. It's clear? A little bit confusing?
On the first FOG, when F is equal to 5, and then you put it to a square, why to a square?
Good question. Look, let me show you. Let me try to explain in another way, more graphically, more clear. The composition is a change of function, and the change, you know, have different steps like that. But in this case, we have only two, because I can interpret a function like a black box. Suppose in that order, the first function that you need to evaluate is G. This is G function. And the second in the chain is F. Okay, I put it two black box, but in this order. And you plug in the value is 2, no? 2, this argument, x equal to. X equal to is our first input. And you evaluate x equal to into the G. I did that. The answer is 5. You remember? And the output of this output, we have 5. But this 5 now get in the second black box. And the second black box, now we have a new input. And you evaluate F. I did here, look, evaluating F, pero the function F, remember, is x squared. So say you square 5, the answer is 25. More clear now, miss?
Super clear.
Okay. Okay. That's it. No. This is just the beginning to understand a function composition. Let me try. In the test, maybe we are doing example, but not necessarily numerical like that. No. Look. Suppose that we have two functions. It's given. Two functions is given. F of x is given. Is x squared plus x plus 1. This is given. Semicolon and g is given. And is 2x plus 3. 2x plus 3. I want to find the expression, the new expression. Guess F composition. Well, let's do it. In this case, a little bit more complicated because we have no number, and the number we simplify the thing. Because when you compute, you're condensing the information. But no. It's easy also because I need to understand that X element go inside F. So the outermost function is F, and the innermost function is G. This is important to understand. Therefore, you take the innermost function and substitution, so you replace X for the completed G inside the outermost function. Therefore, is, parenthesis, 2x plus 3 square plus 2x plus 3, no square, because here we have no square plus 1. Do you understand the thing I am doing or no?
No.
Okay. It's extremely important, the order. F composition G of X. This is my first function. G is my first function. And this G completely go inside F, like that. Therefore, in our specific example, the expression que corresponde with the G, I just replaced by X in F, que is the outermost function. That's the only thing I did. No X anymore. I substitution by 2x plus 3. Clear?
Yes.
I leave it like that? No. This is no elegant. This is totally crazy, ridiculous. So you need to manipulate. The rest is elementary algebra. You foil. I want to do fast because it's 3. No, let's do it in step by step. 2x plus 3 times itself is 4x squared plus 6x plus 6x again plus 9. Plus, I did that part, only that part. Plus, this plus is this plus. I copy this without parentheses because it's not necessary. This parentheses plus 1. That's it. No. Combine like term and end the story. 4x squared, we have 6 and 6 is 12, 12, 14. And 3, 12, 13. Final answer. Do you understand this or no? Okay, but let's do it in opposite direction. Let's do it in opposite direction. Angelina, let's do it in opposite direction. Suppose I want to ask you on the test G composition F. Well. I suppose it's easier. Let me use in green color. You take, in this case, the outermost function in this order is G. Now the totally complete F, okay, I enclose in the green color, I substitution here. And so we have 2 parentheses, no x anymore, no, it's x squared plus x plus 1 plus 3. Do you understand the thing I am doing or no? It's confusing or it's clear? And leave it like that? No. The rest is distributive property and combine later. 2x squared plus 2x plus 5. And it's my final expression. Equation, guy. And this is too easy, Professor? No, it's not easy. It's complicated. I know. I understand very well it's complicated. Very, very complicated. Because the complication is state is domain. Okay, so basically, again, one more time, we're intersecting. Okay, what is the domain of the composition? What is the formula to find the domain of the composition? The domain of composition. Composition maybe is F, composition G, in that order. So domain of this is equal domain of G. Why is important G? Because G is the first function, because it's the first black box and what you get in the domain. Si no satisfy G, it's obvious it's complete out the domain, intersection domain of the new expression. New expression. What is the new expression? The new expression is, for example, this expression or another expression. In this case, this example is not happy to understand this new situation. Let me complicate your life using another example. Suppose we have two functions, f of x equal x over x plus 3, semicolon, g is equal 13 over x. These two functions is given. And the question say, find the expression f composition g first. And secondly, states domain. Okay, let's do it. I suppose it's the last part today. Okay, so I understand that you take the innermost function and replace here and here. So no x anymore. No. Now the new expression is, look at that. The new expression is, at the top we have 13 over x. 13 over x repetition plus 3. Do you see that or no? Do you see the thing I am doing or no? No? Okay. Now, leave it like that? No. We apply a little bit algebra. For example, I multiply top and bottom by x. We have 13 over 13 plus 3x. You understand what you're doing? I multiply by x here, and by x here. This x is cancelled, this x is cancelled, and this no. And this is my elegant new expression. Super. And the domain, wow, domain is complicated because we have two domains forming the whole domain. Domain of G, okay, this is G. I can see in the denominator of G is just x, so x non-zero, illegal zero. This is my first piece. The domain is x such that x non-zero, and domain of the new expression. And the new expression again is the division, and you take the expression and the denominator get 13 plus 3x, and you enforce it to be non-zero. It's illegal. Zero is illegal. Division by zero. Now solve for x. This inequality is, 3x no equal negative 13 divided by 3 both sides. X no equal negative 13 over 3. And this is my domain. Two holes. One hole in 0 and another hole in negative 13 over 3. Entonces en Alex, guy, you need to express this idea in interval notation. But it's super easy. Es from negative infinity, comma, negative 13 over 3, union, negative 13 over 3, comma, 0, que es the other whole, union, 0, comma infinity. End the story. Do you understand this or no? It was similar to the combination. So in conclusion, guys, a few words. In conclusion, we have several ways to combine a function using the classical arithmetic operation: addition, subtraction, multiplication, division. Division is complicated. Remember, division is illegal divided by 0. So this enforces to you to apply another restriction. And combination, or composition, sorry, no combination, composition. Composition is two functions, pero es combined in different way. It's one function go totally inside another function. So we have two functions, the innermost and the outermost. And always the innermost go completely. It's like in my mind, the outermost open your mouth and swallow totally, and the innermost. Okay? Okay, entonces I promise. Okay, remember, next Monday, holiday, enjoy President Day, enjoy doing the homework, no? Or the mathematical homework, no? No, enjoy, I will. And we go over the next day, so Wednesday, start review, and in your moment, I will send the review packet, okay? Plus next month. Thank you for everyone. Good class. I like this class.
Thank you, Professor.
You too.